All right, guys, welcome back. Hey, second semester. Time flies when you're having fun. Hopefully, everyone's safe. Okay. Hopefully, everyone's ready to learn. So, this semester, we'll be doing a lot of math work. All right. So, before we start with any of our modules, we're going to start with module zero, which is basically a review of dimensional analysis or the boxes and squares method. All right. So, what is dimensional analysis, right? Or the boxes and squares format? Okay. Dimensional analysis is nothing more than a proper way of solving problems, all right, where you can actually see the units getting canceled out, and it presents a more or less an ordered, organized format on how to solve conversion problems. All right, so let's try to use this one. All right, so for example, I wanted to convert 1.9 centimeters to meters. Right. Now, you should know by heart a few of the conversion factors, those that are, one, basically, the base conversion factors, right? So, for example, you should know the following conversion factors by heart, okay? You should know that 1 meter is equals to 1,000 millimeters. You should also know that 1 meter is equals to 100 centimeters, right? So you should know those two conversion factors, right? And you need them to be able to convert 1.9 centimeters to meters, all right? So let's start with the format. Okay. So the first thing you want to do in dimensional analysis is draw the boxes and squares. So I want to do these boxes and squares right here. See it? All right, pre-drawn for you. Okay. Remember, guys, nothing goes at the bottom box. The first bottom box, nothing goes there. So you can delete that forever. You can erase it. Okay. So you can erase that. You can erase that forever. So remember, nothing goes there. Okay. In the first top box, that's where your given goes. Okay. So what's the given? The given is always the number in the problem. So if you look closely, the given is 1.9 centimeters. Okay. Right. Now, what goes in the next two boxes, right? The top and bottom boxes. In those two boxes, in the next boxes, actually, if you have more than two, in the next boxes, this is where you put your conversion factor. All right. So you need to look for a conversion factor. So, and remember, you know two of them. All right. So you know 1 meter is equals to 1,000 millimeters, and 1 meter is equals to 100 centimeters. Now, the question is, which conversion factor do we need? All right. It's actually easy. First of all, you need to look for a conversion factor that has the unit for the given and a conversion factor that has a unit for the unknown. Got it? So again, you have to look for a conversion factor that has the unit for the given, and you have to look for a conversion factor that has the unit for the unknown. All right. Sometimes this is just one conversion factor. All right. But sometimes you might need more than one conversion factor. So let's look. For example, the unit for our given is centimeters, cm. So look at those two conversion factors. Who has cm, centimeters? It's right here. Okay. Now I need to look for the unit for my unknown. I want to solve meters. So look at your conversion factor, which has meters. This one right here. Okay. So in this case, you only need the second conversion factor. See it? You only need one. Right. So I need that one right there. The question now is which one goes on top and which one goes at the bottom. It's actually easy. Remember before, guys, we said boxes diagonally across should have the same units. Okay, boxes diagonally across should have the same unit. Since you started with the given centimeters, the next time you should see centimeters should be at the bottom because remember, boxes diagonally across should have the same unit. So cm should be at the bottom. Now look at your conversion factor. What's the number that goes with cm? So cm is right there. And if you look closely, the number 100 goes with cm. See it? All right. So what goes at the top? The other conversion factor, 1m. Do you see it? All right. Now look. Okay, so what do you do now? All right. So we just need one conversion factor, so we're done. Now remember, guys, if you have more than one conversion factor, okay, you have to put more boxes and you follow the same hint. The boxes diagonally across should have the same units. All right, we'll talk about that in a second. All right, so we're done. So what do we do now? All right, now we do math work. So grab your calculator now. All right. So what you want to do now is you want to multiply first horizontally all the boxes at the top. Okay, so I want to multiply all the boxes at the top. So I only have two boxes right here. So I have to multiply these two boxes right here. So 1.9 times 1 is simply 1.9. All right. So what do you do with the non-numbers, the letters? Well, just copy them down for now. So CM and then M. All right. See ya. So that's the top box. Okay. All right. Put a long line. And now let's do the bottom boxes. So I want to multiply horizontally all the bottom boxes, but there's only one thing there at the bottom. It's just 100 centimeters. Okay. All right. So I'm done. Right. So what do we do with these two numbers right here? Now we divide the top by the bottom. All right. So, but before that, if you look closely, you can clearly see there's a cm at the top and then there's a cm at the bottom. If you recall in algebra, okay, variables that are on top of one another, same variables that are on top of one another, you can cancel out. So cm here cancels out with cm here, and that leaves us with our unit m. All right. Now if you don't want to write all these letters at the end, you can actually cancel them out in the problem. Remember, boxes diagonally across from one another should have the same unit. If they have the same unit, they should cancel out. All right. All right. So let's do the math. So now we divide 1.9 by 100. 1.9 divided by 100 is 0.019. And what's left behind is m at the top, and that's going to be our final unit. See it? All right. So let's try this again. Now remember, guys, you need to know a few conversion factors by heart. Okay. All right. So let's look at this next problem right here. In this next problem right here, I actually wrote down some of the conversion factors that you need to know by heart. Well, you should know these by heart. For example, the first row are conversion factors for length. Okay. These are all length. Okay. See it? The second row is a conversion factors for mass. Okay. These are all conversion factors for mass. Okay. And then the third row is conversion factor for time. And then at the bottom one, these are conversion factors for volume. All right. Okay. All right. So let's start. So in this problem right here, how many meters, we're being asked, how many meters are there in 20.3 kilometers? All right. So again, let's set up our boxes and squares. So boxes and squares. Again, nothing goes at the bottom, first bottom box. So cross that out. And then our given goes in the very first top box. So that's 20.3 kilometers. Again, how do you know that's the given? Well, that's the only number in the problem. Okay. Now, in the next two boxes, we need a conversion factor. All right. And again, how do you know which conversion factor do you use? You need to look for a conversion factor that has the unit for the given, and you need to look for a conversion factor that has the unit for the unknown. Again, sometimes it might be just one conversion factor. Sometimes you might need more than two or more. All right, so let's see. The given is kilometers, so that's length. So I need to look for the first row, and I can clearly see kilometer is right here. Do you see it? All right. Now, the unknown is meters or M. So I need to look through this first row again. And which one has M? I see it right here. Therefore, I only need one conversion factor. It's this one right here. See it? And again, how do I know which one goes at the top? Is it 1 kilometer on top or is it 1,000 meters on top? So again, boxes diagonally across should have the same unit. So kilometers is the given. Kilometers should end up at the bottom now. Kilometers right here. Remember, boxes diagonally across should have the same unit. All right. Now look at the number with kilometer. What's the number there? 1. See it? So 1 kilometer goes at the bottom. So what goes at the top? 1,000 meters. Y'all see it? All right. And since we only have one conversion factor, we're done. Okay. Remember, guys, boxes diagonally across, since they have the same unit, the unit cancels out. Okay, now we can do our math work. Okay, so we need to multiply the top, okay, all the boxes at the top. So 20.3 times 1,000 is 20,300. Okay, let's write down all the letters that we didn't write down. So it's just M, okay, over, multiply all the boxes at the bottom, but there's only one box at the bottom, and that is 1, right? And that is 1, okay? And therefore, that's just going to be 1, all right? So 20,300 divided by 1 is 20,300, and the unit is meters. See it? All right. Okay, very good. Let's move on to our next problem. So again, what if you have more than one conversion factor? That's what we're going to look at in our next problem, right? So let's try to use now two or more conversion factors. All right. So look at this next problem right here. Okay, it looks very, very similar to our last problem. How many What is mm? It's millimeters. Don't forget. Are there in 20.3 kilometers? All right. So let's again set up our boxes and squares really quickly. Again, nothing goes here. Okay. By now, you should know that nothing goes here. And then you got 20.3 kilometers right here. All right. So let's look for our conversion factors in the table. All right. So first of all, let's look for km. I see km right there. All right. Now we need to look for a conversion factor that has mm. All right. So wait a minute. Look, I see two of them. I see this and I see this. Okay. The question is now, which conversion factor should I use? Okay. You want to use the one that has the most similarity with each other. All right. So look, are there anything similar between these two? Okay. No. Right. How about these two? Yes. You see the M and the M. So I don't need this conversion factor. What I need is the last one. So I need two conversion factors, this one and this one. See it? So again, we have two conversion factors. All right, so let's start. Okay, so in the first two boxes, which conversion factor should I use first? Is it letter A or is it letter B? So which one do we need first? Okay, again, guys, boxes diagonally across must have the same unit. The given is km, so km must be at the bottom here. So again, diagonally across, they must have the same unit. Remember? All right. So which conversion factor has km? It's the first one, so it's this one. Okay. So we use A first. Okay. Now look, what's the number again with km? It's 1. All right. So what goes on top? 1000 m. Remember, you have to use the entire conversion factor. See it? Oh, 1000 m. There you go. All right. So now we're done with conversion factor A. Once you're done with this, never use it again. Okay, don't forget, once you're done with it, don't use it again in the same problem. All right. Now, since we have two conversion factors, I need to add more boxes. See it? And now let's look at B. All right. So I got 1m and I got 1000 millimeters. All right. So which one goes on top and which one goes in the bottom? Again, boxes diagonally across must have the same unit. So M, see it, must be at the bottom now because we see M at the top. Therefore, M must appear next at the bottom. All right, so look at our conversion factor. What's the number? Okay, M goes right here. What's the number that goes with M? Look at your second conversion factor. You can clearly see it's 1M, right? So what goes at the top now? It's 1000 M M. All right. Remember, guys, we only got two conversion factors. So again, we're now done. And we're never going to use this again in the same problem. So again, we're now done. All right. Before we continue, remember, boxes diagonally across from one another should have the same unit. Therefore, they cancel out. So the kilometers here cancel with the kilometers here. See it? The meters here cancels with the meters here. All right. Guys, I'll give you a hint. If they don't cancel out, you did something wrong. You got it? All right. There should only be one unit left, and it's always going to be the top last box. Okay. All right. So let's do our math work. So 20.3 times 1000 times 1000. Remember, we have to multiply all the top boxes horizontally. So 20.3 times 1000 times 1000 is 20,300,000. So it's 20,300,000. Okay. All right. And in the top box, the last unit that we have is mm. All right. Let's draw a straight line and do all the bottom boxes. Okay. So again, you want to multiply all the bottom boxes horizontally, and that's just 1 and 1. So 1 times 1 is 1. And therefore, the answer here is 20300,123. And the answer is millimeters. Right. Okay. Okay, you can actually write this down in scientific notation, and again, that would be one of our videos. Go look back in the YouTube channel that's on your Canvas page and look for how do you write down scientific notation, right? So if we wanted to report this in scientific notation, I would move the decimal place, which is found after the ones place, which is right there, okay, and move it such that I only have one non-zero number to its left. So I'm going to move it 1, 2, 3, 4, 5, 6, 7. And so it becomes 2.03. And remember, times 10, I moved it 7 times to the 7th power millimeters. And that's going to be my final answer right there. See it? And that's how you do boxes and squares dimensional analysis. All right? Let's do one more problem. Okay, and again, you can pause the video, for example, when we're setting up stuff, so you can do your own problem solving first, and then you can check by playing the video whether you got it right or wrong. All right, so let's try it out. Here we go. All right, what if I wanted to convert 34 milliliters to liters? All right, so again, okay, pause your video and set up your boxes and squares. All right. So if you set up your boxes and squares correctly, you should have drawn a quadrant like this. You should have crossed out the bottom right here because nothing goes there. And you should have put in your given, which is the number in the problem, in the first top box. Okay. Right. Now I want you to look for the conversion factor that you need. All right. Okay. So if you did this correctly, you would have looked at the unit of the given and looked at the table. All right. So I see ml right there. Okay. And then you should have looked at the unit of the unknown and looked at the table again. And you can clearly see there's two of them right here and right here. But remember, you want to look for boxes that have something similar to one another. Or if you look closely, they're in the same box right there. So you only need one conversion factor, which is this one right here. Okay, so I need to figure out again which one goes on the top and which one goes at the bottom. So go ahead, figure it out. All right. So remember, boxes diagonally across must have the same unit. So ml is in the given at the top. Next time you see it, ml should be at the bottom. Okay, diagonally across, remember, same unit. What is the number with ml? It's 1,000. Okay, and therefore 1 liter goes at the top. See it? We're done. All right. Let's cancel out first units. Okay. Boxes diagonally across have the same unit, therefore they cancel out. Right. Now you want to multiply top boxes first. Multiply everything at the top horizontally. So 34 times 1 is simply 34. And there's nothing left behind except for L. So let's write that down. Over Multiply everything at the bottom. There's only one box at the bottom. It's 1,000. Okay, no units left behind. So 34 divided by 1,000 is 0.034 liters, and that's the answer. Again, if I ask you to write this down in scientific notation, remember you would move that decimal point until there's only one non-zero number before it. So I would move it 1, 2, and then we get 3.4 times 10. And since we moved it to the right, this would be negative 2, and this would be liters. And that's going to be the answer for this one right here in scientific notation. All right? Okay. There are other few examples. There are a few more examples in this one right here. Okay. For example, this problem right here needs a lot of conversion factors. All right. And we're going to see that this one is very long. All right. So, for example, look, I want to convert 1 year to seconds. So, this is in time. So, look, okay, we're going to do this really quickly. So, again, the given is 1 year. Okay. Right. YR is here. Okay. So I want to convert 1 year to seconds. So if you look at your conversion factor, 1 year is where? Right here. And seconds is where? Right here. Okay. You see it? All right. But there's nothing common in between these two. There's nothing common between these two. That means you have to convert from one unit to another. All right. So look closely. I'll tell you how to do this in sequence just by looking at your boxes and squares. So first of all, okay, which conversion factor do we need first? Okay, so again, it's going to be obviously the one that has the year. So this will be our A first conversion factor. And again, boxes diagonally across must have the same unit. So year must be at the bottom. And this is 1. And then what goes on the top? It's 365 days. That's our conversion factor A. See it? All right. Remember, boxes diagonally across, the unit cancels out. Okay, now look. Now we have days at the top. So we need to look for a conversion factor that has days. Okay, to cancel this out, remember, because we want seconds and not days. So look, that's your conversion factor. Which one has day? This one right here. Okay, so therefore, 1 day goes at the bottom. We need to add more boxes. And then 24 hours goes on the top. Right? The days cancel out. All right. Now, are we done? No, we're not, because we still need seconds and not hours. So this is B, right? This is B. Remember, once you use a conversion factor, you're done with it. Never use it again. So we're done with this. So we're done with this. So I don't use that again. So we need to look at the other three ones. All right. So which one has an hour? All right. Hour is right here. This will be the third conversion factor, C. Okay. 1 hour goes at the bottom, again, diagonally across. Remember, they have to have the same unit. And then 60 minutes goes on the top. All right. Are we done? No, because again, we need seconds and not minutes as our last top unit. Okay, so now we need to look for, remember, done, don't never use it again. Okay, now we use the last conversion factor, which has seconds, and which is this. And this is going to be our last conversion factor. So 1 minute goes at the bottom, and then 60 seconds goes on the top. Cancel, cancel. See it? And now we're done. Remember, guys, the very last top box should have your unknown unit, the unit that you want to solve for. All right? All right. This might seem a bit intimidating, but it's just math work. So what we do now is you multiply everything at the top. Okay. So I need to multiply 1 times 365 times 24 times 60 times 60. So go ahead, do that on your calculator. Right? And if I did my math right, and hopefully I did punch it right, I should get 31,536,000 seconds because that's the last unit at the top, right? Over, multiply all the numbers at the bottom, but if you clearly see there's only one, 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 so one times one times one times one is simply one. And the answer here is actually 31,536,000 seconds right there. All right. Hopefully, you learned about dimensional analysis. If you want more examples, you can just Google on YouTube, for example, dimensional analysis. It's going to show you some other videos that can help you learn how to do dimensional analysis. All right. Okay. Hopefully, you all had good learning experience. And again, guys, please make sure to review the modules, all right, before you do any of our assignments. All right. Thank you. Have a great day.